Voyager 1, which launched on September 5, 1977. Of which almost 44 years 4 months 9 days 17 hours 11 minutes 14 seconds has happened and covered 14.4 billion miles. In which it's revealed many mysteries. But how and why this mission is so important and how it attempt many record of its name. By the help of Voyager 1 we discovered water on one more planet except Earth, Mars and Moon. So let's get answer of these questions in this episode. Its beginning happened from Cape Canaveral Launch Complex 41 on September 5, 1977. One benefit of launching spacecraft on that time that is in every 175 years the whole solar system planets came in row, so for saving fuel and exploring many planets in one attempt NASA launched it in the end of 1970s. It visited Jupiter, Saturn, and Saturn's largest moon, Titan. In the journey of solar system it captured 19,000 images of Jupiter and its satellites. And also discovered active volcano on Jupiter, satellite low. It was probably the greatest surprise for humanity that on any other body the active volcano present. By the images sent by Voyager 1 and 2 scientists understand the physical, geological and atmospheric processes go on in the planet, its satellites and magnetosphere. Afterwards it fly toward Saturn. It aimed to study closely to Saturn rings and the larger moon, and during this journey Voyager 1 found an abundance of new data regarding the planet and its moons. Specifically, it found 3 new moons, namely Prometheus, Pandora, and Atlas, in which Prometheus and Pandora are shepherding moons of the F ring and Atlas is a shepherd of the A rings. And it was confirmed by Voyager 1 that these moons mostly composed of water ice. And a significant data obtained by spacecraft about Saturn's largest moon, Titan, that it has a thick atmosphere which is rich in nitrogen. It's similar to Earth where nitrogen percentage in atmosphere around 78%. But its surface pressure is 1.6 times higher than Earth's. Similarly, it found Saturn's upper atmosphere to be composed of 7% helium and the rest mostly made up of hydrogen. Scientists infer that because of Saturn's atmosphere composition, Saturn radiates more heat than what it receives from the Sun. Voyager 1 also discovered the G rings of the Saturn. After the encounter of 21 years with Saturn, in August 2012, Voyager 1 entered in interstellar space and became the most distant human-made object in space. It consists of the Golden Record, which contents selected by a committee chaired by Carl Sagan. This consists of 115 images and a variety of natural sounds such as those made by surf, wind and thunder, birds, whales and other animals. To this, they added musical selections from different cultures and eras and spoken greetings from Earth people in 55 languages, and printed messages from President Carter and UN Secretary General Waldheim. These whole data sent with the hope that, if it come in coverage of any advanced spacefaring civilizations in interstellar space, then they can get sign of a habitable planet where life advancing their technology. It also consists of the most advanced instruments such as high-gain antenna, magnetometers and low-field magnetometer, ultraviolet spectrometer, infrared radiometer, interferometer, and spectrometer, IRIS, photopolarimeter subsystem, PPS, low-energy charged particle instrument, hydrazine thrusters, micrometeorite shield, optical calibration target, planetary radio astronomy and plasma wave antenna and radioisotope thermoelectric generator. Voyager 1 has 3 radioisotope thermoelectric generators, RTGs, mounted on a boom. Each MHW RTG contains 24 pressed plutonium-238 oxide spheres. The RTGs generated about 470 W of electric power at the time of launch, with the remainder being dissipated as waste heat. The power output of the RTGs declines over time due to the 87.7-year half-life of the fuel and degradation of the thermocouples, but the craft's RTGs will continue to support some of its operations until 2025. On February 14, 1990, Voyager 1 took the first family portrait of the solar system as seen from outside, which includes the image of planet Earth known as pale blue dot. Soon afterward, its cameras were deactivated to conserve energy and computer resources for other equipment. The camera software has been removed from the spacecraft, so it would now be complex to get them working again. Earthside software and computers for reading the images are also no longer available. On February 17, 1998, Voyager 1 reached a distance of 69 astronomical units, 6.4 billion mile, 10.3 billion kilometer, from the Sun and overtook Pioneer 10 as the most distant spacecraft from Earth. Traveling at about 17 kilometers per second, 11 miles per second, it has the fastest heliocentric recession speed of any spacecraft. As Voyager 1 headed for interstellar space, its instruments continued to study the solar system. Jet Propulsion Laboratory scientists used the plasma wave experiments aboard Voyager 1 and 2 to look for the heliopause, the boundary at which the solar wind transitions into the interstellar medium. As of 2013, the probe was moving with a relative velocity to the Sun of about 61,197 km per hour, 38,026 miles per hour. With the velocity the probe is currently maintaining, Voyager 1 is traveling about 523 million km, 325 million mile, per year, or about 1 light-year per 18,000 years. Voyager 1 became the first spacecraft to cross the heliopause in August 2012, then at a distance of 121 astronomical units from the Sun, although this was not confirmed for another year. As of September 2012, sunlight took 16.89 hours to get to Voyager 1, which was at a distance of 121 astronomical units. The apparent magnitude of the Sun from the spacecraft was -16.3, about 30 times brighter than the full moon. The spacecraft was traveling at 17.043 km per second, 10.590 miles per second, relative to the Sun. It would need about 17,565 years at this speed to travel a light-year. To compare, Proxima Centauri, the closest star to the Sun, is about 4.2 light-years distant. With a spacecraft traveling in the direction of that star, 73,775 years would pass before Voyager 1 reaches it. Voyager 1 is heading in the direction of the constellation Ophiuchus. In late 2012, researchers reported that particle data from the spacecraft suggested that the probe had passed through the heliopause. Measurements from the spacecraft revealed a steady rise since May in direction of the constellation Ophiuchus. In late 2012, researchers reported that particle data from the spacecraft suggested that the probe had passed through the heliopause. Measurements from the spacecraft revealed a steady rise since May in collisions with high-energy particles, above 70 MeV, which are thought to be cosmic rays emanating from supernova explosions far beyond the solar system, with a sharp increase in these collisions in late August. At the same time, in late August, there was a dramatic drop in collisions with low-energy particles, which are thought to originate from the Sun. Voyager 1's extended mission is expected to continue until about 2025, when its radioisotope thermoelectric generators, RTGs, will no longer supply enough electric power to operate its scientific instruments. Thanks for watching. For now, like, share and subscribe.